Section 1. Most people building AI agents are staring at the wrong problem. They're trying to make the model smarter, tune the parameters, switch to a bigger LLM when the actual bottleneck is sitting right there in the prompt itself. Context Gateway is a middleware layer that compresses the bloated context your agents send to LLMs before it ever reaches the model. And the results are genuinely interesting. Here's what it actually does. When your AI agent runs, whether it's a LangChain pipeline, an AutoGPT-style loop, or a custom tool calling agent, it accumulates context. Conversation history. Tool outputs. Retrieved documents. System instructions. By the time that context hits the LLM, it can be enormous. Context Gateway sits between your agent and the LLM endpoint and compresses that payload. It strips redundancy, summarizes repetitive exchanges, removes low information content, and passes a leaner, more focused context to the model. In practice, you're looking at real token reduction. Think about a multi-turn agent conversation that's been running for 15 steps, tool calls, intermediate results, retries. Without compression, you might be pushing 12,000 tokens into every call. Context Gateway can bring that down significantly, which means lower latency, lower cost per call, and in many cases, better model outputs because you've removed the noise the model was having to wade through. The architecture is proxy style. You point your agent at the gateway endpoint instead of directly at OpenAI or whatever LLM you're using. The gateway intercepts the request, applies compression strategies, and forwards the leaner context downstream. No changes to your agent logic. No changes to your LLM. It's a drop-in middleware layer. Section 2. Now let's be honest about what this does not do, because there's real nuance here. Context Gateway is not magic summarization. It's not an AI that deeply understands your domain and intelligently curates what matters. The compression strategies are largely heuristic and structural, things like deduplication, truncation of older turns, collapsing repetitive tool outputs. If your agent is doing something where every single token in that history genuinely matters, legal document analysis, precise debugging traces, scientific data, aggressive compression could drop critical information. You have to tune it. It also does not solve the context window problem fundamentally. If your agent is architected in a way that requires all 100,000 tokens to be present simultaneously, compression buys you time and money but doesn't change the underlying design constraint. The real solution there is retrieval augmented generation or smarter agent memory. This isn't that. It's not a semantic router either. It won't decide which tool outputs are relevant to the current query and which aren't in a deep reasoning sense. It's operating on structure and patterns, not meaning. And right now, and this is important, it's early stage open source. The documentation is thin. Production edge cases are not all covered. If you're deploying this in a high-stakes pipeline today, you're an early adopter, and you should treat it that way. Test thoroughly before you trust it with anything critical. Section 3. So where could this realistically go? A few directions that actually make sense given what's already here. First, adaptive compression. Right now the strategies are somewhat static. A natural evolution is context-aware compression, where the gateway looks at what the agent is currently trying to accomplish and makes smarter decisions about what to preserve. If the agent is in a retrieval phase versus a reasoning phase, the relevant history is different. That's buildable. Second, cost observability. Because the gateway sits in the middle of every LLM call, it has a unique position to log token counts, track compression ratios over time, and give you a real dashboard of where your token budget is actually going. That kind of observability tooling would be genuinely valuable for teams running agents at scale. If you're hosting something like this on DigitalOcean and serving multiple agent pipelines, that telemetry layer becomes infrastructure you actually need. Third, integration with memory systems. Context Gateway could become the interface layer between short-term in-context memory and longer-term vector memory, deciding in real time what gets compressed into the context versus what gets offloaded to a retrieval store. That's a more ambitious roadmap, but the architectural position is right for it. Fourth, and this is the one I find most interesting, model-specific compression profiles. Different LLMs handle context differently. GPT-4 and Claude and Mistral don't all degrade the same way when context gets noisy. A gateway that learns the compression profile optimal for each target model could meaningfully improve output quality, not just reduce cost. Section 4. So why does this exist? What problem is actually driving it? Here's the thing that doesn't get talked about enough in the AI agent space: we've spent enormous energy making models better at reasoning, better at following instructions, better at tool use. And that's all real progress. But the way we're feeding those models is still pretty naive. When you look at a typical agent loop, an agent that's been running for a while, accumulating history, calling tools, getting results back, the context it sends to the LLM on step 20 is a mess. It's got the original system prompt, 15 turns of conversation, half of which are no longer relevant, tool call outputs that were useful 3 steps ago but are now just noise, retried actions that failed, redundant formatting wrappers. And the model has to process all of that every single time. We've been treating the model as the expensive thing to optimize. Context Gateway is betting that the prompt itself is the inefficiency, that what you send to the model matters as much as which model you send it to. That's a meaningful reframe. There's also a cost argument that's hard to ignore. At scale, token costs compound fast. If you're running a production AI agent that handles thousands of sessions, even a 30% reduction in average context size translates to real money. The engineering time to integrate a middleware layer pays off quickly. The deeper insight here is that prompt engineering has focused almost entirely on what you write: system prompts, few-shot examples, chain-of-thought instructions. Context Gateway is focused on what you remove. And sometimes what you remove matters more than what you craft. That's the bet. And honestly, it's a reasonable one.